Okay, welcome back to this next video in this series looking at the higher tier only content in the Combined Science specification magnetism topic. In the previous two videos we've introduced the motor effect, and then we've looked at Fleming's left-hand rule, which told us the direction of the force acting on a current carrying wire in a magnetic field. What we're going to look at in this video is the equation which will allow us to work out the size of that force, or indeed work out, if we knew the force, for example, the size of the current. Now we've already seen the different factors which affect the size of the force on our current carrying wire, and the equation is a relatively straightforward one. So the force is equal to the magnetic field strength. Now we have a special name for the magnetic field strength. It's called the magnetic flux density. So when you see this term, magnetic flux density, it just means magnetic field strength. Multiplied by the current, multiplied by the length of the wire which is in the magnetic field. Okay, and just about fit that on the screen there. So force is magnetic flux density multiplied by current multiplied by the length of wire. Now let's have a think about the units for this. We know already that force is measured in newtons, we know that current is measured in amps, and we know that length is measured in meters. So the one we haven't met before is magnetic flux density. And magnetic flux density is measured in a unit called Teslas. So Tesla symbol is capital T, named after Nikola Tesla, who was a scientist. You may also have heard it in the context of the electric car manufacturer. So here is our equation, and the good news is this is given to you on the equation sheet, so you would not have to learn this equation. You just need to be able to use it, and you need to obviously know these units. So because you're given it on the equation sheet, you are also given the symbols for it. And because this is quite a lot to write out, it makes sense to do this in symbol form. However, there are a couple of strange symbols to be aware of. Force is F, that's nice and logical. Magnetic flux density, though, for a reason I'm not quite sure, is given the symbol capital B. Current is given the symbol capital I. You might have seen that one before. And length is given the symbol L, which is again logical. So we've got F equals B times I times L. Some people like to remember it as F equals Bill. If you're not confident though using the equations, you can always write it out in words. That will never be a problem, so you can always do that. So the best way that I think now, just like with Fleming's left-hand rule, for you to get to grips with this is to practice some questions, and hopefully then if a question on this comes up in your exam, you'll feel confident being able to use it.